اوكي، إذا نبدأ القصة هلا ب solving some exercises or example about determination of the position of the element in periodic table. In this example number 5, write the electron configuration of the following elements or atom: carbon, sodium, oxygen, phosphorus, and nitrogen. To write the electron configuration, we must know the number of electrons in each one. From the atomic number to deduce how many electrons from atomic number Z, from atomic number Z, we start by writing in a neutral atom. دايما أنا بدي بلش فيها هي in a neutral atom number of electrons equal number of protons equal to Z. So for carbon has 6 electrons. The electron configuration K and L. K carries 2, L carry 4 electrons. For sodium Ne, the Ne has an 11 electron. The electron configuration K2, L8, we have 10 electrons, so we need another energy level M. So we have the total 11 electrons, 2, 8, 10, and 1, 11. Oxygen has 8 electrons. The electron configuration is K2, and we have 6 electrons on L. Phosphorus 15 has 15 electrons. So K2, L8, M5. The sum of 2, 8, 10, 5, 15. The last one is argon, AR. AR has 18 electrons. The electron configuration starting by K, L, M. 2, 8, 10, and 8 we have an 18 electron. بهالشكل كتبنا نحن electron configuration of this element. Determine the position of each element in the periodic table. Position, row, and column. Determine, we must write the definition of each one. What is the meaning of row and the meaning of column? Row, according to the definition, row of a number of energy level that carries electron. Column of a number of valence electron. So for carbon, if we return back to the electron configuration of carbon, carbon has K2, L4. We have 2 energy level. Row 2 has 4 valence electron. So here row 2, column, as we say, when we have more than 2 valence electron, we add 10. So column 14. Sorry, we have the number of column of carbon is 40. For oxygen we have 2 energy level. 2 energy level also. Oxygen in row 2 we have 2 energy level. 2 energy levels, which are K and L. And column is 16. We has 6 valence electron. 6 valence electron. For element sodium, we have 3 energy level. Row 3. Also for argon, 3 energy level. Row 3. We have phosphorus, 3 energy level. All of these elements in row 3. sodium has 1 valence electron, it is in column 1. We have 8 valence electron, so it is in column 18. We have 5 valence electron is in column 15. So we can write for sodium and the row 3 column 1. Phosphorus row 3 column 15. Argon row 3 also column 18. Row 3 and 3 energy level. There are 3 energy levels that has electrons which are K, L and M. For example, why it is in column 15 and the 5 valence electron. Why it is in column 18? We have 8 valence electron. For the third part, we write use the periodic table. We must use the periodic table to indicate the atomic number for the following elements: chlorine, calcium, helium, fluorine, sulfur, potassium, K, and silicon. If we return back to the periodic table, fluorine, we have oxygen has an 8 atomic number, so fluorine has an atomic number 9. Phosphorus and 13 for aluminium, 14 for silicon, and 15 has 15 atomic numbers. Sulfur has 16, chlorine has 17, and so on. Potassium will has a 19 atomic number, calcium we have 20, and helium has an atomic number 2. Then, by using the periodic table, chlorine has an atomic number Z is equal to 17. Calcium has an atomic number is equal to 20. The helium has an atomic number 2. Fluorine has an atomic number 9. Sulfur has an atomic number 16. Potassium K 19. You can return back to the periodic table or referring to a periodic table. As we say previously, we count and we find the atomic number for silicon is equal to 940. Okay. The fourth part in this example, write with justification the electron configuration of the following element. We will explain how to write the atomic number of the following element, an atom R that is found in row 3 and column 18. For atom R, row 3, it means that on the 3 energy level, 3 energy levels occupied by electron. Okay. Level occupied by electrons, which are K, L, and M. Column 18 mean there are 8 valence electron. 8 valence electron on the last energy level M. So the electron configuration of R is K2 L8 M8. And then we have found we write the electron configuration of an atom R. The second atom X, row 2, by the same way as explained in part A, يعني عندي 2 energy level carries electron or carrying electrons which are K and L. Column 14 يعني we have 4 valence electron. Column 14 and the 4 valence electron on the last energy level L, so the electron configuration will be K2L4. This is the electron configuration of atom X. For the other elements, atom D, row 4 is on row 4 and the 4 energy levels carrying electrons which are K, L, M and N. Column 1 يعني there is only column 1 يعني the 1 valence electron in N level. In the outer energy level N, we have only 1 electron. So the electron configuration is K2, L8, M8, and N. The last energy level has 1 valence electron. The previous energy level must be completed by the maximum number of electrons, 2 for K, 8 for L, and M has 8 electrons. The last atom G, row 2. Row 2, this means we have 2 energy level K and L. Column 16, this means we have 6 valence electron. So we have K2L6. We found or we realize electron configuration of this missing element or mysterious element are X, D, and G starting from their position in the periodic table. Okay, let's continue with example 4. In example 4, we have the lowest dot symbol of some chemical atoms: helium, fluorine, potassium, argon, and sulfur. Indicate the number of non-bonding electrons pair. Non-bonding electrons pair in lowest dot symbol in general, if an element is represented by an X like that, for example, this pair of electrons is known as non-bonding pair, or it is known as lone pair. The other that found or exist as a single dot like these are known as bonding electrons or single dot electron. Okay, so to find the non-bonding electron, helium has only 1 pair, so helium and the 1 pair. Fluorine, we have 1, 2, and 3, so fluorine has 3 pairs. 3 pairs. Potassium, K, no pair. It has only a single dot electron. Argon has 1, 2, 3, and 4. So argon, we have 4 pairs of non-bonding electron. Sulfur, 1, 2, so sulfur has 2 pairs of non-bonding electron. The second part identifies the number of columns, the columns number. As we take the definition of column depend is on the number of valence electron it indicates, and from the number of valence electron. The lowest dot symbol represents the valence electron. Lowest dot symbol represents the valence electron in the atom. So, for fluorine has 7 valence electrons, 2, 4, 6, and 7. So, and he column 17, since we have 7 valence electrons. Potassium, K, column 1. It has only 1 valence electron. 1 valence electron. Only 1 valence electron. Argon, Er, column 18. We have 2, 4, 6, and 8 valence electron. We have 8 valence electrons. Column 18. S, column 16. Also we have 6, 2, 4, 5, and 6. And the 6 has 6 valence electron. For helium, in helium it has 2 valence electron. The helium has 2 valence electron. It is found or located in column 18. This is an exception for helium. Helium is not located in column 2. It is found or located or placed in column 18 since the electron configuration of helium is only K2. It has only K2. This energy level is a saturated or a complete energy level. Saturated energy level or a complete energy level, like argon. The argon, the Ar, as in part previous example, it has an energy level K2, L8, M8. It has a complete energy level, complete K level. We have L is saturated by 8 and M is 8. Any energy level when an element has all its energy level are completed by its electron, so it is placed in column 80. This is an exception for helium only since it has 2 electrons. To write the electron configuration of S, E, R if they are in row 3, and we have 3 energy level K, L, and M. So for S هيكون عندي K2, L8, M6. We have 6 valence electron. AR Yeah, this is AR, has 3 energy level KLM, and we have an 8 valence electron. Okay, for helium in row 1, this means it has only 1 energy level, and since has 2 valence electrons, so in first energy level we have only 2 electrons. So the electron configuration is K2F, has an outer energy level. This means there are K energy level and L energy level. Yeah, outer energy level, the last energy level is L. We have K and L. K carries 2 electrons and fluorine has 7 valence electrons, so we have K2L7. To deduce the atomic number, we must find the total number of electrons. Since atom is neutral, we must explain how to find the atomic number. Deduce, we mean to justify how to find the value of the atomic number. So since atom is a neutral, this means number of electrons equal number of protons equal to the atomic number Z. So to find the atomic number of the first element in this example, which is S, well, S carries a total number of electrons is 16, 2, 8, 10, and 6 electron. AR has a total number of electrons 2, 8, 10, and 8 is an 18 electron. So for sulfur إذا بنقول النمبر of electrons is equal 2 plus 8 plus 6 is equal to 16. We must answer as follows. In the official exam in grade 9, we must make calculation of the total number of electrons 2, 8, 6, 16 electron. Then Z is equal to 16. For argon, number of electrons is equal 2 plus 8 plus 8 equal to 18. So Z is equal to 18, the atomic number of argon. The helium has only energy level K, only one energy level, which is K2. This is for helium. So for helium, and the number of electrons is equal to 2, so its atomic number Z is equal to 2. For fluorine, number of electrons is equal. We have 2 and 7. 2 plus 7 is equal to 9, so its atomic number Z is equal to 9.